There is the idea that life might have been intentionally spread throughout space and seeded on the surface of other worlds by a guiding intelligence. A detailed version of this hypothesis was put forward in 1973 by the molecular biologist Francis Crick, co-discoverer of the structure of DNA, and Leslie Orgel, Crick and Orgel 1973. The chances of microorganisms being passively transported from world to world across interstellar distances, they felt, were small. The probability of successful seeding would be greatly increased, they pointed out, if the fertilization were carried out deliberately by an existing technological civilization. Their argument depended first upon demonstrating that it was possible for an advanced extraterrestrial civilization to have developed in the galaxy before life first appeared on Earth. This they were able to. As for the means of dispensation, the spaceship would carry large samples of a number of microorganisms, each having different but simple nutritional requirements. For example, blue-green algae, which could grow on CO2 and water in sunlight. A payload of 1,000 kilograms might be made up of 10 samples, each containing 1,016 microorganisms, or 100 samples of 1,015 microorganisms. Crick and Orgel further suggested that directed panspermia might help resolve one or two anomalies in the biochemistry of life forms on Earth. One of these was the puzzling dependence of biological systems on molybdenum. Many enzymes, for example, require this metal to act as a cofactor. Such a situation would be easier to understand if molybdenum were relatively abundant on Earth. However, its abundance is only 0.02% compared with 0.2% and 3.16%, respectively, for the metals chromium and nickel, which are chemically similar to molybdenum. Crick and Orgel commented, if it could be shown that the elements represented in terrestrial living organisms correlate with those abundant in some types of star molybdenum stars, for example, we might look more sympathetically on infective theories. A second example they give concerns the genetic code. Several orthodox explanations of the universality of the code can be suggested, but none is generally accepted to be completely convincing. It is a little surprising that organisms with somewhat different codes do not coexist. The universality of the code follows naturally from an infective theory of the origin of life. Life on Earth would represent a clone derived from a single set of organisms. There might be a variety of reasons why an advanced civilization would wish to intentionally initiate life elsewhere, as an experiment in astrobiology using an entire world as a laboratory. To prepare a planet for subsequent colonization, see terraforming, or to disseminate the genetic material of the donor world to ensure its survival in the event of a global catastrophe. Exposed by A.R. Borden and J.W. Barber, Catastrophism, Exopolitics and Return of Nibiru, a case for the long-term or extended view of exopolitics, Life Physics Group, California and Institute for End-Time Studies, 2006. The first account of directed panspermia arose in 1930 within a science fiction novel, Olaf Stapledon's Last and First Men. The novel follows the history of humanity across the span of 2 billion years, during which the human species transform into 18 different men. The first men are attributed to our own species, which almost die out because of a subterranean explosion in the 24th century and split up into two subspecies 10 million years later. The 18th men, residing on Neptune and on the brink of extinction, decide to spread life to other worlds. 43 years before the publication of Crick and Orgel's paper, Stapledon wrote the following. In respect of the future, we are now setting about the forlorn task of disseminating among the stars the seeds of a new humanity. These objects we shall project from beyond our atmosphere in immense quantities at certain points of our planet's orbit, so that solar radiation may carry them toward the most promising regions of the galaxy. Thus, while Stapledon did not use the term directed panspermia, the central concept of the theory originated within his piece of science fiction. The last men, in spite of their hyper-advanced civilization, realize that their species is doomed. Their planet of Neptune grows rapidly hotter due to a supernova infecting the Sun, and they are left with no choice but to create a new sentient species on another planet before their demise. While Stapledon identifies our human race with the first man, the 18th species of human does, in some ways, resonate with us. Just as Neptune grew hotter, so too is global warming rendering parts of our planet inhospitable. There are already numerous studies, for instance, on the possibility for Saturn's moon Enceladus to sustain Earth-like life or directed panspermia. The most popular account of directed panspermia among 21st century science fiction can be found in Douglas Adams' The Hitchhiker's Guide to the Galaxy, which is worth reading for its excellent premise. Another critical study which preceded Crick and Orgel's paper was J.B.S. Haldane's The Origin of Life, published in 1954, in which he conjectures that the origins of life came from seeds launched into space by intelligent beings. This reasoning was extended a decade later in Carl Sagan's Intelligent Life in the Universe, where he outlines the panspermia hypothesis. Sagan, in contrast, labels directed panspermia untenable as a fundamental concept, particularly given that the conditions of the universe 20 billion years ago would have deemed the existence of life highly improbable. Notably, there have been various studies and concepts of life being eternal and living organisms transmitting themselves from one planet to another rather than simply arising from non-living matter. It is the directed part of panspermia hypotheses which the aforementioned studies contributed to theories centered on the plurality of worlds. Finally, we arrive at Crick and Orgel. Their argument to support the theory of directed panspermia developed the following reasoning. The chemical composition of living organisms must, to some extent, reflect the environment in which they evolved. Thus, the presence in living organisms of elements that are extremely rare on Earth might indicate that life is extraterrestrial in origin. They hone in on the example of the Earth metal molybdenum to substantiate their thesis. Given that the abundance of molybdenum on Earth is only 0.02%, whereas we may find that it is abundant on another planet, this could provide evidence to suggest that life did not originate on Earth. Their second point centers on the universality of the genetic code, which alludes to life being descended from a clone derived from an individual extraterrestrial organism. In response to their argument about the abundance of molybdenum on Earth, a group of biologists based at the University of Colorado argued that molybdenum is more abundant than initially outlined by Crick and Orgel. For instance, they highlight that it is relatively abundant in seawater, and also suggest that it is no less abundant on the planet than chromium and nickel, the two other elements which scientists have determined vital for animal life. Further, they point out that, in working out the respective abundances of the three elements, Crick and Orgel used the average values for the whole Earth in their figures, which is misleading. However, the aim of this paper was not to denounce the theory in its entirety, but to aid those interested in developing a more sophisticated approach. Thus, it seems that the concept of directed panspermia attracted the attention of even the most skeptical of scientists. The reason why directed panspermia gained momentum in the 1970s can be attributed to developments in space exploration, rocket propulsion, and air flight, all of which contributed to the worldwide construction of astroculture. The persisting popularity of science fiction further fueled scientific curiosity about the origins of Earth. Interest in panspermia has been sustained by the Earth's current circumstances in relation to climate change concern. Crick and Orgel make a very relevant comment in their paper. In view of the precarious situation on Earth, we might well be tempted to infect other planets if we became convinced that we were alone in the galaxy. As aforementioned, there have been studies on how directed panspermia could be achieved using today's technology. In their paper on a hypothetical extraterrestrial colonization program, for instance, Roy Sleater and Neil Smith argue that we have the tools necessary to not only set sail for the stars, but to colonize them. On the other hand, Other scholars have outlined the negative implications of directed panspermia. Gary O'Brien, for example, uses procreative ethics to reason that creators have an obligation to their sentient creations, which cannot be met in directed panspermia missions. Indeed, there is no guarantee that the newly created sentient animal life will live a life worth living in an unguided biosphere. O'Brien concludes, "We have a duty to provide our creations with a reasonable chance of flourishing, but we cannot possibly know what life will evolve on our selected planet and whether they will lead a good life." Thus, humanity may need to find a less unethical route to safeguarding humanity against the risk of extinction. Thus, directed panspermia in the 1970s was taken up by scholars out of pure interest, but ultimately dismissed because of the dubious evidence surrounding it. In the present, discussions about directed panspermia center around how we can sustain our own life, rather than on how extraterrestrial beings may have done so on Earth. We are instead looking towards the future rather than the past. Arguments for directed panspermia focus on the possibilities for life to be sustained for 3.5 billion years further than predicted, which could be especially important if we are the only living beings in the galaxy. Zero, on the other hand, directed panspermia poses the risk of interfering with other indigenous life elsewhere in our solar system, or introducing these new beings to a possible life of suffering. It is my view that these implications alone render directed panspermia highly problematic. Rather than focusing on how we can use this concept, it would be far more interesting for scientists to redirect their attention back to the origins of life on Earth, as Crick and Orgel originally proposed.